A 150-ton mining excavator stripped to its core and rebuilt into a 351-ton giant they call the Jumbo, reaching 16 stories high. But converting raw digging power into controlled vertical demolition meant solving a problem most engineers wouldn't attempt. Engineers began with a standard Caterpillar 6015B hydraulic mining shovel. Built to dig heavy earth, this original platform weighed between 140 and 150 tons. To pivot from earth-moving to high-reach demolition, the team spent over a year stripping the machine to its bare frame. Through a 3,000-hour design collaboration, Lorini Officine Mechanics handled the custom fabrication, Caterpillar secured the core architecture, and Despe defined the field requirements. They rebuilt the shovel into a 351-ton giant capable of working up to 48 meters, or 157 feet, re-engineered for extreme vertical loading and torsional stress. Because the forward demolition arm behaves like a lever, moving a heavy tool further from the pivot point dramatically increases the tipping force. To keep the machine anchored, engineers completely rebuilt the foundation. They widened the track frames by 2.5 meters on each side, creating a 10-meter wide footprint. This undercarriage assembly alone weighs nearly 100 tons. For transport, 4 built-in hydraulic cylinders lift the entire machine off its tracks, utilizing quick-release connections to detach the frames without needing an external support crane. To balance the front-heavy reach, standard concrete ballast was swapped for denser lead within the same footprint. A modification claimed to add 20 tons, paired with an extra modular counterweight block at the rear of the superstructure. A mining shovel concentrates its power on downward digging forces. Demolition requires the exact opposite, lifting massive tools high into the air. Lorini replaced the original digging arm with custom modular demolition booms. In its shortest 18-meter configuration, the machine carries tools weighing up to 25 tons. For extreme elevation, the maximum height configuration carries an 8-ton tool, while intermediate configurations at 30, 36, and 42 meters balance reach against attachment weight. To manage these swaps, automated hydraulic pin connectors in the boom adapter secure each module quickly without manual rigging. To operate high-demand tools, engineers had to solve a major hydraulic puzzle. They kept the original Caterpillar C27 ACERT engine at its factory 813 horsepower. Instead of boosting raw engine power, they rebuilt the plumbing. Through custom programming and secondary line routing, the system allegedly delivers over 800 liters of fluid per minute to the tool. Flow represents the actual volume of pressurized oil circulating through the system rather than engine strength. It is this high volume of fluid that allows heavy steel shears and concrete crushers to cycle and bite through reinforced structures without stalling. Looking up at 48 meters exposes the operator to falling concrete and steel. To prevent neck strain and maintain visibility, the entire cab hydraulically tilts backward by up to 30 degrees. This adjustment changes the pilot's line of sight without altering the boom's working geometry, all while enclosed in a certified rollover and falling object protective cage. Moving this custom Titan requires breaking it down. Crews disconnect high-pressure hydraulic lines to separate the massive 73-ton upper superstructure from the undercarriage. The entire machine splits into approximately 12 or 13 transport modules designed to fit on standard flatbed trucks. Once on site, a specialized crew can reassemble the entire excavator in roughly a day. Traditional demolition forces a choice between working height and tool weight. This configuration breaks that compromise, offering 3 combined advantages: extreme vertical height, massive tool capacity at mid-range, and safer physical separation from falling debris. In tight urban areas where wrecking balls or explosives are banned, it allows for top-down dismantling of buildings up to 16 stories. Heavy processors crush concrete and cut reinforcing steel floor by floor, lowering ground vibrations and structural shockwaves that might damage neighboring foundations. Project documentation attributes the rapid dismantling of the Curva Sud Morosini stand at Gewis Stadium to this mechanical capability. Beginning June 8, 2023, the machine systematically crushed the concrete tiers in a fraction of the expected time. While height represents one axis of difficulty, density presents another. Some industrial structures resist demolition through shear mass rather than elevation. In these scenarios, the machine's shorter, heavy-duty configuration handles tools far heavier than the 5-ton limit typical of standard high-reach excavators. This high-capacity design is engineered to target heavily reinforced, thick-walled structures, including nuclear containment domes, cooling towers, steel mill foundations, chemical reactors, concrete silos, and heavy bridge abutments. When dealing with overbuilt concrete, reducing the reach concentrates the hydraulic system's massive flow into pure, close-range crushing force, easily fracturing the thickest structural mass. Unstable ruins pose an unpredictable threat. Blast-damaged masonry and fire-weakened frames can collapse without warning. By operating far from the immediate danger zone, crews establish a protective buffer, working upwind to keep clear of toxic chemical and industrial residues on hazardous sites. But the work extends beyond concrete demolition to direct steel processing. Instead of pulling down a massive structure all at once, the machine carries heavy industrial scrap shears directly to the upper levels. It cuts structural steel beams, heavy industrial piping, and towering distillation columns at refineries and power stations in place, separating clean scrap at elevation for efficient recycling. As modern skylines grow taller, we face a new challenge: dismantling the past. The Jumbo proves that tomorrow's engineering isn't just about building up, it's about safely bringing it down.